After drawing the columns, now I will draw the beam. Here, draw option, draw beams, quick draw beams. So here also both options are present. So here I will click draw beam. Here I have only defined one beam, so that's why only one beam is appearing here. So now draw beam here. You can click one by one, but here you can see software automatically make the beam for each panel. Right click, or you can click the click select mode. The automatically draw mode will disable. So now I have also drawn the beams, draw panels, slab. So now I will define or draw the design strips. So for the design strips, I will go edit, add slash edit design strips, add design strips. First of all, in the X direction, I will grid direction X and the strip layers are A. Okay, so here you can see grids are defined. So now I will click edit, edit design strips, Y, and the name is P. What are these design strips? These design strips are used for the designing of slabs by using strip design method. So when we design, after that we will display the results by using design strip method. So that's why we are defining. Now I will in the draw the Y direction. Here you can see. So these are extra. You can delete or trim, but if they are extra, no need. So of software only give the results which are present on the slabs. So now you can also draw by yourself. For example, here I am deleting one grid, one design strip. Okay, now I will draw design strip. Okay, so that's A direction for the X, and that's a column strip. So the start width at right, it's left, and right width and end width at this. So you can adjust accordingly. So here I am just putting 5 feet at the start, 5 feet, 5 feet. But when software draws, software automatically determine the design strip widths. Here is the start, here is the end. I will right click, close. So that's how you can also manually draw the grids. Now I have almost drawn. Load combinations are also defined. Now I will run the analysis and design. For automatic mesh, software automatically make use rectangular mesh 4 feet by 4 feet. Okay, so now I will run analysis and design. Okay, after running the analysis, you can see the finite element model. Okay, this is showing the deformed shape for that in inches. So when you move your cursor, you can see the deformation. Here is downward deformation is minus 0.06. Here is minus 0.087 inch. Here is minus 0.089. So here in the color you can also see here is very less deformation. So now in the display you can also see the show of deformed shape against load combinations. For example, 1.2 that plus 1.6 live apply. Okay, so here now the deformations are more because now the dead and live both are present. So now I further move for punching shear, so that my shear check is okay or not. Here the for the beams not need to calculate, but for the drop panels which are provided, that are okay. All the demand versus capacity of shear is okay, so it should be less than 1. So you can optimize here. So now the drop panel, that's value is 0.26. You can decrease the slab thickness to 6 inch, and the drop panel maybe 10 inch. So you again run the analysis, then this value will optimize, will maybe reach near to zero point 0.8, zero point 0.6, which is also okay. So now I will display show slab design. Here is design basis strip based. Okay, so now I will click the layer A and layer B, apply. So now you can see on the whole of the slabs, the strips data, the reinforcement data is given, top and bottom reinforcement in inch square per feet. So for example, I will take any panel. So for example, let me zoom this portion, this end grid here. So now for example, when I will move in the edge, so here is a top and bottom. You can see at the edges top area is more, bottom is reducing. Similarly in the slab, bottom area is there, no need of top. Similarly here you can see. So you can also impose the minimum, that's a requirement of the code, apply. So it means the minimum reinforcement will govern, because the reinforcement which is calculated against the loading, that is very low. So we will provide the minimum reinforcement, because minimum reinforcement is governing the criteria. Okay, now you can also see this same method. For example, in the a finite element. So here is the finite element. Okay, now for the one direction is the x direction, and the two direction is the y direction. Now I will see the bottom reinforcement by finite element method, apply, impose also minimum reinforcement, apply. Here you can see at the columns there is no need of reinforcement, but in the center there is a need of reinforcement in the x direction. Similarly, for example, let's see in the top in the y direction, apply. So here only at the columns top steel is needed, in the span in the mid of the beam spans, no need of reinforcement. So you can also calculate the reinforcement. For example, here is a typical uniform reinforcement. For example, number 4. Let's see that will be okay or not. For example, in the top, apply. Okay, so there is still need of reinforcement. I am reducing the spacing. You can step down by uh, in increments. Here now you can see more. For example, in this at the draw panels, extra reinforcement is needed. So for the example, for the bottom steel, apply. Okay, in the bottom 4 inch 8 inch by 8 inch spacing is okay. For example, let's see 10 inch by 10 inch, apply. Okay, so there is some, at some points there is a need extra steel. So that's how you can design the slabs uh, in SAFE software. So say here, apply. For example, if I am saying apply, So here is an enforcement. When I apply provide the enforcement number for 10 inch in the top, number for 10 at 10-inch spacing uh, at bottom. Apply in layer A and layer B in X and Y both direction, also applying the minimum criteria. So here almost every area is covering, only just here. So here you need to provide extra steel. Close. Now there is one beautiful function, that is a detailing. In the detailing you will definitely first set the preference, the unit system, all the things. Then the detailing for the slab reinforcement, what bar area you prefer. Here is a minimum, for example maximum 4. So let's see design, just select the number 4, enable also minimum, that is definitely 0.0018 bh, which is the minimum enforcement criteria. So prefer the bar size, definitely point number 4. In the column strip middle and column strip top and middle strip, top and bottom. Okay, detailing, there is also further, for example drawing sheet size, drawing format properties. After that you have set the preferences, just click run detailing. So here is the detailing. So you can detailing, you can see the detailing from here, or in the explorer window you can also see all the drawings which are generated by the software. So here is a slab views, that is a framing plan which is appearing here, and bill of quantities, rebar schedule. Okay, slab views, rebar plan, for example top rebar plan. Okay, bottom rebar plan. Similarly section 1, section 2. Okay, what are the locations of the sections you can see in the framing plan, section 1, section 2. So that's how you can detail, and for further study you can print these drawings and study these drawings. One thing we have not see in the results, that is a beam design. Here I will go in the uniform shape, software automatically come in the original shape. Here I will see display, show beam forces and stresses. In that we will see the, for example moments, shear. For example in the load combination I will select second combination, measure moment. Here you can see, because we have provided the beams at the perimeter, at the mid there is a moment, at the support there is a negative moment, positive moment, negative moment. And for example if you want to see major shear, here is also major shear diagrams. Close. Now I will go in the display, show slab design, show beam design. In the beam design I will see the longitudinal rebars. Okay, so here is for flexure and torsion. So here I'm saying the for the flexure, apply. So here what are the, for example at top, at the mid there is no need of top reinforcement, only bottom. So when I go at this port, there is no need of bottom reinforcement, only top. So that's how you can design the beams uh, in CSI SAFE software. Close. For the beam drawings, software also created the beam drawings. For example, here is the beam framing plan, individual view. Uh, here is a concrete section, elevation of full beam, and sections. Software also shown the sections. So you can study in details the detailing of CSI SAFE, and you can also edit by exporting into the export view in the AutoCAD DXF format, AutoCAD drawing format. Close. So what is checking software? This software CSI Safe is checking that the AutoCAD which is installed on this laptop, is it compatible or not. So just that. After that, you can export and you can edit there the drawings. So that's all for slab design with draw panels in CSI Safe software.